Today we're going to be taking a look at the Ender 3 V3 Plus. Through a little bit of camera trickery, I make this thing look kind of small through forced perspective. But let me get back in line with this machine a little bit. This is how big it really is. You know, I can stick my head through the middle here. It's quite large. So in this video we're going to talk about what this machine is, what its pros and cons are, and whether or not it's right for you and where it fits into the marketplace in general. So there's a lot to learn in this episode. If you're interested in picking one of these up, check the affiliate links down in the description below. Also, it might be worth checking out the affiliate links to the Creality K2. They're doing a pre-sale and it's going to be like 50% off. That's going to be like a super large Core XY machine, but we don't know how well that machine's going to perform yet. Based on what I've been seeing from Creality in the past 3 to 4 months, I think they've really kind of cranked up the quality a little bit on their designs, and we'll be taking a closer look at that with this machine. Okay, so what's the deal with this printer? It's basically a gigantic bed slinger. This is about as big as you'd really want to make a high-speed bed slinger. Now you can make bed slingers much larger than this. A good example of that is with the CRM4. It produced one of my favorite, oh crap, I'm breaking this thing already, hold on. Produced one of my favorite prints to date, my 4-kilogram trash can print. This thing's been through a lot. You can see all of the scratches and scuffs on here. I've been using it to support heavy loads, and I use it as a trash can and occasionally as a bedpan. So, you know, that's a really nice print. You can make bed slingers really large. It's just, once you get past about this size, the weight of this bed slinging back and forth ends up having some pretty detrimental effects on print quality and limits how fast you can print. They have a bunch of models preloaded that I can run. One of them is a 14-minute speed Benchy, and in my opinion that's a little bit too optimistic for this machine. The print quality on that Benchy was pretty bad. I might as well just fire one up right now so you can see. Basically, when you have a bed that large, it ends up having a bit of an issue accelerating back and forth a lot. That's not as big of a problem on large prints. So this print, for example, it's got long straightaways and a lot of straight lines with the infill. So it's quite fast. And also prints like this is just my typical 3D printer test print that I like to run. It's made by, hold on, he didn't write his name on here. That seems like a missed opportunity. But anyways, you can see on these large prints, it's able to pull them off. So in terms of just printing out large objects, I think this would do a great job. I made a special profile for this where I slowed it down a little bit and I turned up the extrusion because I think they have a little bit of tuning left to do on this machine. Maybe that's a topic for later in the review. But I was able to sort that out with just some tweaks in the slicer. Speaking of the slicer, a lot of people have complained that Creality Print is running on a forked version of Cura, but the newest version of Creality Print, let me just fire it up so you can take a look. This is the newest version of Creality Print. All of the controls are different, and that's because they've switched from using a Cura-based slicer to a Bamboo Studio / Feversoft version of a slicer. And I'm pretty sure they're doing that in anticipation of their new K2 Max or K2 Plus, which is going to be a 350 by 350 absolutely massive Core XY machine that will have a multicolor capability that's very similar to what Bamboo Lab came out with the AMS. So I'm excited to see what that's like, and I guess a big part of, you know, copying that whole multicolor workflow is getting on the same type of slicer. If we go over into the device tab, this is going to be the same multiple printer management system that they have in their previous versions of Creality Print, which I really liked. I think one of the things that Creality is doing really well compared to the competition, even, you know, higher end companies like Prusa and Bamboo, they have a really good interface here, and setting up your network is really simple. You can just type in your Wi-Fi information and get connected that way, instead of having to fall back on using an app or something else to get set up on the internet. Also, you're not forced to sign up for any accounts or anything. They have super fast file transfer speeds, so most of my G-code files get sent in under a second. Let's talk about this machine though. This is the star of today's video, so let's get into the details. Now basically this is a larger version of the Ender 3 V3. I've reviewed that thing previously. I used it as one of my primary printers for a couple of weeks while I was producing parts for my own custom 3D printer design. And well, here goes the speed Benchy, so pardon the noise in the background, but you know, you're probably interested in seeing this anyways. So yeah, Creality with this machine, they just wanted to take that existing design and scale it up. So instead of a 220 by 220 build area, they've got a 300 by 300 build area here, and it's significantly taller. And this size is really running into the limitations of how big you can make a bed slinger. This speed Benchy demonstrates this concept pretty aptly, I think. Like, this thing is just too big to be moving this fast. It's actually a little bit scary. Like, I store things under my desk, so sometimes I'll be reaching down to grab something and I'll be like, ugh, because I'm worried that this bed will just fling over and hit me in the head. And it probably weighs about 1 kilogram. You've got this metal thing that can just jab you or hit you in the eye or something. So yeah, I mean, you got to be a little bit careful of this thing because the bed will protrude out the front a little bit. Also, I had situations where it would bump into my hands while I was using the touchscreen. So you definitely want to get down here like this and stay under that little line of where this bed is. Personally, I would prefer if this screen was relocated either off to the side, like it is on 90% of Ender 3s, or even up to the top. Like if they put it up here and I could dial in my stuff up there. It's just right here. It's really close to all this stuff that might hit you, which is kind of silly if you ask me. I've got this thing set up with the spool holder up top. In the stock configuration, it's hanging off the side here, which I didn't really like because as the gantry moved up and down, it would kind of get a tangle of wires back here. And I was always like checking on it and making sure nothing was getting caught up in the wires. So I think it's much, much better with the filament spool holder up top like this. I just had to drill a couple holes into the frame, which are actually there on the original Ender 3 V3. It's just they left them out on this model. So I've advised Creality to, hey, you know, put those holes back on here. There's already like thickened pads there where the metal is slightly thicker, so you can tap into that. I rerouted the wires in the filament path just because I thought, you know, it made it a little bit better and cleaner and more aesthetically pleasing. I would recommend setting this up like this if you end up getting one of these. The Core XZ motion system is something that is really uncommon in the 3D printing space because, frankly, it's just more expensive than a traditional Cartesian motion system where you just have like your Z-axis lead screws and your other whatever. It's just a lot more complicated. I don't know if it's more expensive, but it's definitely more complicated. I did a couple of test prints. One of them was this tower. This printed completely. I just broke this off after the fact, so ignore that little broken piece there. But yeah, there's this tolerance test that a lot of printers will do, and they're like, wow, look how impressive this is. We printed a hole, and then we printed a pin inside of the hole, like this, and look at that. It falls right out because the tolerances are so good. But really what they're doing here is they're just under extruding. So you end up reproducing the pin that's actually smaller than it is in the CAD model. So it's like, wow, it passed all these tolerance tests, but it's coming at the expense of under extrusion. Like, this part feels lighter than what it should be. And I'm sure this Benchy will end up a little bit underweight as well. And when I take a look at this is a test print that I did. Let me get a light to backlight it, and you'll see something kind of suspicious here. Look at that. Okay, of course it's slightly transparent, but on top of that you can see there's gaps in this extrusion. And this is 3 stacked layers of plastic, and you can still see through it, kind of like a mesh. And to me, that's just too much under extrusion. Like, that's too much. They didn't dial in their steps per millimeter. So the way that I fixed that, it wasn't too difficult. On this one, I made everything much more solid. There was no gaps between the layers, and you can see all of these layers of top extrusion look quite nice. Everything's joined together. I was able to fix it just by turning up the flow multiplier in the slicer. So this part is nice and dense. It's printed to, you know, the full strength of what PLA should be. I hate underextrusion. It produces weak, fragile, brittle parts, and everyone should just be extruding either perfectly or even over extruding a small amount. In terms of reliability, I haven't had any issues with the extruder or the hot end or anything. This is, as far as I can tell, the exact same tool head that's on the Ender 3 V3. The hot end and extruder is pretty similar to what's on the K1, but they've done some slight upgrades and tweaks to it to make it more reliable and just better overall. And they also added a one-piece unicorn nozzle, they're calling it. But basically they've combined the heat break and the nozzle into one piece. So you screw that in as one unit, that goes up into the thing, and that'll help prevent those leak type failures. You know, the blob of death where if the nozzle comes loose or something and then plastic starts seeping out everywhere and you get a big blob built up on the print head, that's much less likely to happen on the Sprinter because of the way that it's constructed. That means you'll have a harder time finding replacement nozzles, but I'm sure the aftermarket will flood with options for that soon enough. You just gotta give it a couple months for people to start manufacturing them. Okay, what else? Well, let's talk about what's different on this machine from the Ender 3 V3. First of all, they're using larger motors for the X, Y, and Z motion. So the Core XZ system here, I'm not sure if these are larger. They seem a little bit bigger than what's on the Ender 3 V3. On the Y motion system, which is what moves the bed back and forth, they actually have two motors. So there's a motor in the front and a motor in the back. All the pulleys are driven, and that helps increase the stiffness and make it more symmetric in terms of how much springiness the belt adds to the system, regardless of if it's at the front or the back of the bed. Like, it makes a lot of sense for kinematic reasons. It adds a little bit of cost, obviously, because you have an extra motor in there, but I think it was necessary to move this big bed back and forth. So you've got two pulleys, one on the front and one on the back, and they're both smaller than a typical 3D printer pulley. Most 3D printer pulleys are 20-tooth pulleys. These are what appear to be 16-tooth pulleys. So those are going to be a little bit smaller in diameter. And what do we know about pulley laws and torque calculations? Well, when you make the diameter of the pulley smaller, that's going to increase the amount of force you can pull on the belt. So that helps improve your acceleration and speeds that you can get on this thing. Well, it doesn't improve speeds, but in practicality, you're more limited by your acceleration when you have a big heavy bed like this. Because what do we know? Force equals mass times acceleration. So acceleration equals force divided by mass. So, you know, obviously you want to make the bed as lightweight as possible, which honestly I'm not sure Creality did the best job of here. It's quite chunky and it's causing quite a bit of vibrations here. But you can also increase how fast you can accelerate the bed back and forth by using smaller diameter pulleys. That'll get a better gear reduction and be able to pull that bed back and forth more quickly, which, I mean, clearly it's doing quite well here. You know what, this speed Benchy actually doesn't look that bad. I take back some of the criticisms that I have. I would say it's typical speed Benchy quality. Really not awful for how fast this is going. Now this thing has input shaper and fully automated bed leveling. It's got 4 load cells built into the base of the machine, so it just taps the nozzle to figure out where the bed surface is and also to account for any unevenness in the bed. What else is different between this machine and the smaller version of the Ender 3 V3? Well, it's got these back supports here. I think it actually looks quite nice. Instead of using just a round tube, they went with a rectangular section tube, which actually looks pretty slick here. It's painted to color match the rest of the machine. Now let me just pull this off. Parts come off nice and easily because we've got a textured PEI build surface here, which is thankfully what Creality is shipping on most of their higher end machines now. So it's textured PEI on one side. On the other side, this appears to just be black paint. But honestly, I don't mind having a second side because if I wanted to, I could flip this over and apply some 3D printer bed adhesive, which I've become more and more of a fan of lately. Or you can put like blue painter's tape or whatever you want on the other side. So, you know, I did this big print, which I'll talk about in just a minute. You know, I'm working my way around this printer. It's got a 350 watt power supply, just like the Ender 3 V3 and most other smaller 3D printers have. So you're getting better print volume, but you're not having to worry about greater power consumption, which I guess is kind of nice if you're running this in an office where your circuit breakers are nearing their limits. But yeah, I mean, the biggest and most significant difference has got to be the weight of this bed. Now, they've done a good job compensating for the weight by using larger, thicker bearings there. Like, this thing is quite solid for how big and fast it is. So I think they did a decent job in the design of this structurally. It's just, if anything, they could have made it a little bit lighter. We'll take a close look at this Benchy, I guess, right now. What do you think of this Benchy? That's actually really not bad for a 14-minute Benchy on a giant bed slinger like this. So, yeah, not too much to complain about there. So I do like the way that this thing works. Would I buy something like this if I was printing out a lot of speed Benchies? I don't know, probably not. The reason why you would buy this machine over something else is because you need that larger build area. I had another printer in for review, the Artillery X4, and I just couldn't do a video about that thing. I spent an entire week trying to fix it and get it to lay down a consistent first layer, but I couldn't get it to work. So I think that's an issue that a lot of companies have when they're moving from the smaller bed size to a larger bed size, especially if you're doing these thin spring steel sheets and they try to cheap out and make the aluminum as thin as possible. When you heat the bed up, then it starts warping and doing all sorts of weird stuff. With Creality, they definitely spec'd this correctly. They made sure not to skimp out on this bed. It's quite heavy, but it's because it needs to be heavy in order to resist those bending forces and, you know, stay relatively flat as you're running a print and the temperature's changing and all that kind of stuff. Let me go over the things that I like about this machine before I really start tearing into it for all the little nitpicks that I have. One thing that I really like about all the latest Creality machines is their touch interface. I just unplugged it, so I can't demonstrate it. But you've seen this in a bunch of other places. They've got a USB Type A port over here, so you can take any typical flash drive or SD card adapter and just plug it in over here to get your print started. Also, another cool thing about how they've implemented their firmware, when you start a print off of the SD card, the first thing that it does is copy that print onto the internal memory on board the computer for this machine, and then it starts the print. So you can actually unplug the SD card while it's printing, and it just keeps running because it's already transferred it onto the computer on board the machine. I already talked about how it's quite narrow, but even front to back, it's quite skinny. Now, it does take up a bit of extra space because of the bed moving backwards and forwards. And this part, you know, I'll get into this when I get to my gripes about this machine, but the bed flying so far forward out, it's like an external guillotine that's ready to bop you in the head. But we'll talk about that later. Anyways, we're focusing on the positives here. It's got a nice high quality base. This is all die cast aluminum. So is the frame. Even on my larger prints, this one took 14 hours and was almost an entire spool of filament. I think it was like 600 or 700 grams of PLA. I had no issues or really even concerns about this machine just because it's been running pretty well since I've got it plugged in. Print quality looks quite good. Bed adhesion, you know, I think they nailed all the important things in terms of getting this printer built right. In terms of the looks of this machine, I just really like the way that it looks. It's really clean, aesthetically speaking, lightweight, pretty easy to move around. So overall, I think this is just a good design, both aesthetically and mechanically. It's nicely polished. The Hotend and Extruder are somewhat mature designs at this point because they've been iterating over several versions of this hardware, and it's finally at a state where it's functioning reliably and repeatably. I like the little LED that lights up on the front of this logo and just the really easy to use touchscreen. So yeah, I mean, those are all the good things that I have to say about this printer. If you were planning on buying one of these, make sure to just stop the video now and click on my affiliate links and go buy one. But now I'm gonna get into the, you know, the not so good things about this machine. Both the nice to haves and also, you know, the WTF Creality parts of the build. But before I get into that, I want to tell you about today's sponsor, JLC 3DP, and also JLC CNC machining services. So I was able to build this gigantic, awesome printer which fortunately there's just barely enough room for in my office. So I've got this all set up in here, and yeah, I'm going to be doing some more development on this thing as we go along. JLC 3DP and JLC CNC, they offer these services to get your custom machined parts made. So all of the parts that I designed for this machine I had produced through their service, and they turned out quite nicely. The machining on these is excellent, and the pricing is also excellent. It's a service that I used before they were a sponsor, and it's something that I'll continue to use even after they're a sponsor if you know, for some reason they stop sponsoring my videos. If you want to have your own custom parts machined, or you want to get some parts 3D printed out of SLA or powder-based processes that you just don't have access to, go to jlc3dp.com and use my code. I think you get a discount or something. But in any case, it's just a really nice service to be able to have access to additional materials and manufacturing capabilities. You know, most of you have 3D printers, but you probably don't have a CNC machine or a powder-based 3D printing machine or an SLA machine. So just being able to have access to all those different materials and processes is really nice, and I really appreciate having JLC 3DP on as a sponsor because it allows me to do cool stuff like this. You know, being able to design my own stuff is something I've always wanted to do on this channel, and with their support, it's a heck of a lot more possible than it was before. So head to jlc3dp.com right now if you want to get some parts made. They have an online quoting engine, so it's really easy to just send your parts over, get a quote, figure out how much it's going to cost, and then, you know, if you want to buy it, then you can go ahead and buy it. I think that's a good segue into the gripes that I have about this machine. So number one, it's just a little bit too loud. Right now it's got just one fan running, but when the whole thing was running you could hear it. It was quite loud, and it makes kind of like those high-pitched whining stepper motor noises too. But it had peaks like nearing 70 decibels. And I'm in a pretty well sound insulated room here, but when I was going out, I could hear this machine down the hall. In terms of mods or things that I had to change, I reconfigured a lot of the wire pathing. Also, when the spool holder was mounted here over on the side, it just took up an extra, basically, you know, whatever the diameter of a spool is. It took up that much extra space off the side of this machine, which I wasn't a fan of. Like, this thing already takes up enough space as is. Adding an extra 100 or 200 millimeters off to the side just makes it enormous. And one of the benefits of the way that they've designed this machine, at least for the rest of the frame, is that it's actually quite thin. Like, you look at the extra space that's required on the left and right of this machine, it's basically just the width of the build plate plus a little bit extra for these pillars, but you know, when you mount the spool up top like this, it's really slim, and I could fit several of these on a desk. I kept talking about how the footprint is small and, you know, you can stack these together, but since it's a bed slinger and this bed is moving forwards and backwards, you're really limited on the in the areas you can put it. Like, if I move it back to this point, it's sort of bumping into the wall just barely with the cable here. This is about as far back as I can push it on this desk. If you have a narrow desk, like a much narrower desk, then this wouldn't fit on it because you'd have that issue of this bumping against the wall in the back. So you end up having to kind of scooch it up towards the front of the desk, and then when it's up here, you have to worry about the bed coming all the way out front and bumping into things, and it's sticking out like 4 inches here, and you've got these basically sharpened blade tabs on the on this that could, like, these could seriously, that could draw blood. If you have a fast travel move like whoop, and it just whacks you. Even if you're just walking around, you know, this could bump into you and skip some steps. Or in my case, if I'm reaching for something under my desk, like I'm grabbing the suitcase or something, I have to watch out because this thing could just like kabunk, you know, knock me out, and that's the end of the Nathan Builds Robots YouTube channel. And the other thing that I don't like, and I've rambled about this a couple times already, is the mess of cables and Bowden tubes and all this stuff that was off to the right side in the stock configuration. I relocated all the wires to run up the side of this right-hand support and exit up top here along the right side. I could have fed the Bowden tube in the normal path and had it come from around back and feed into the extruder, but I really don't think that's an optimal path because when you go up to the top here, it forces the Bowden tube into a tight bend radius to go up and then back underneath this this top piece. And the printer, when you start a new print job, it homes at the top. So it's not like it's this rare condition that it's going to be in. It's always doing this where it moves up to the top. And if you have some really stiff filament, let's say you're printing with carbon fiber PLA or something, and it's loaded in this tube, and it goes up to the top and it bends the filament and it snaps it, then that's going to ruin a print and cause a bad day for you. I think this thing is really designed to have the filament running in from the top. Like, look at how clean this filament path is. It goes straight from, you know, the spool up here directly in to the print head, and it's just nice and clean. Like, this is the way that it should be set up from the factory, in my opinion. So, you know, even when it goes down to the bottom and then let's say it goes back up to home, there's enough slack in the system, the way that it's set up, that it doesn't cause issues. It's something that you'd probably want to keep an eye on and make sure you don't have like tangles and stuff forming there. But I didn't have any problems with it set up like this for the multiple prints that I ran. All the parts that are in blue were run off this filament being hung up at the top here. In terms of the print quality, I think it's quite good. It could be better, but at the same time, I'm not going to complain too much about this because it's good enough. Here you can see I've got a little bit of like oozing or something that occurred. It's got a large melt zone on this printer. This thing can melt a lot of filament, so I mean that's not an uncommon thing to see. In terms of the overhang performance, it did quite well all the way up to 60%. I mean 60 degrees. There's like perfect print quality there. All the way up to 70, like you guys might find this quality perfectly acceptable. I'm having a hard time explaining this on camera. Hold on. Okay, so here you can see this is 75 degrees and it's starting to have a little bit of issues. It's able to print it, and like it wouldn't cause a failed print to have that going on. And this is all the way up at 75 degrees, so that's a really good result. And then at 60 degrees, we've got perfect layers there. Even all the way up to 70 degrees, a lot of you would call this perfect. No, sorry, this up here, the one that's obviously bad, that's 80 degrees. So up at 80 degrees, you start getting your first little bits of failure. But even up to 70 degrees here, it's looking quite good. This is the 70 degree mark. So, you know, part cooling on this thing is quite good. And that's one of the advantages that you have with a bed slinger. Ooh, I just wheeled myself back and cut myself a little bit on this edge. So again, you know, these tabs sticking out and all that is a little bit of a problem. I don't know, there's got to be a better way to do it. I know on the Flash Forge machines, they actually have a plastic handle on the front. Other things about this machine that I'm not the biggest fan of, this is a big one that is an issue with more printers than it should be, and that is the stock printer profiles are just not good enough. Most of these models are just pre-sliced models that were on the machine that I printed out, and those are good to have because it allows you to just print things and see how it works. But this was the first model that I sliced myself. I'll peel this brim off so it's not distracting you. But this was the one that I was showing you that you could see light through. And it's just massively under extruded, and it's really weak because of how under extruded it is. Like those layers aren't adding much strength. So yeah, print profiles aren't the best. Something that I think they need to do is slow the machine down. Like, this isn't a speed printer. I mean, it's quite fast for its size, but it's not going to be like a true high-speed, ultra, you know, insane acceleration printer. It can reach high speeds, you have to turn the accelerations down a little bit because of how heavy this bed is. I turned my accelerations down, depending on the feature. I was printing between 2,000 and 4,000 millimeters per second squared, which is plenty fast, and it's not that big of a deal. And I was getting great results. It's just, you're not gonna be able to hit like 8K or 10K or 20K like you might be able to do on a Core XY machine. But then again, when you're printing large models like this, you don't have a whole lot of fine details that require high accelerations to produce quickly. If you're producing a small little Benchy like this, yeah, you have to crank up the accelerations to be able to get it done in a reasonable amount of time. But for something big like this, even if you cut the acceleration in half, it's not going to slow the print down that much, just because, like, you know, this big long line on the edge. So, you know, acceleration, not too big of a deal there. I do think they're a little overambitious with their stock profiles with how high they have the acceleration set. Personally, I think you should just slow it down a little bit and produce high quality prints. Like, there's no point in printing something fast if it's not going to be of high quality. Part of that is probably because they have a new slicer. I guess that makes sense that the slicer settings aren't all tuned in yet. But Creality has a tendency of releasing machines and not releasing really good slicer profiles with them, which is something that really needs to change. Like, I should get this machine, just run the stock slicer settings and be able to get good solid prints off of it, not have to go in there and figure out how to adjust the flow multiplier and get it so that it's not under extruding. That's a little bit annoying. Also, this interface is a little bit simplified. Now, this is counterbalanced by the fact that on all of their new stuff, people have been able to flash these over to using standard Clipper, so you get full control over the machine once you just flash it to the, you know, Clipper firmware. But the Creality version of Clipper that they have flashed on this machine from the factory is a little bit dumbed down, so when I go into this menu here, I can't change things like the flow multiplier or the acceleration limits or that kind of more advanced features. Which is fine, or is it? You know, should we have access to those options? I would say, Creality, it's okay for you to take those options away from us once you've made sure the machine is tuned right. But if you send it out like this, where it's under extruding and it's causing these little gaps to appear in your models, you see these little gaps, then you should allow people to fix those while the printer is running. I mean, it's a crazy concept. The under extrusion isn't an issue with the hardware, it's just how they've tuned it. So when I turned up the extrusion multiplier in this print, everything worked fine. So yeah, I mean, the machine needs a little bit more tuning. In terms of the hardware though, I think it's doing pretty good. Here's one of the sample prints that they included, and it printed all these spires without breaking. Now, I broke this one after it finished printing. But yeah, I don't want to make too many excuses for Creality. Like, that's something that they should have really had sorted out. They're already selling these machines. This isn't like an early release model or anything. They're already shipping and selling these, so it's like, this is the time when it should all be sorted out. So, you know, there's some stuff that needs to get worked on there. I kind of wish it had a light up top, like if they integrated a light bar into this machine. They put a light on the print head so the little Creality logo lights up, but I don't know. Light bars are something that aren't really necessary, but they're really nice to have. This doesn't come with a camera for monitoring your prints. Personally, I rarely use that feature, so I don't really miss it. But they have an included print that I guess you can attach a camera to right here. And I guess this gets attached down here. And then you can like point your camera at your prints as they're going along there. And yeah, that's the other thing that's kind of frustrating about this machine is the hardware is let down by the firmware and the software that they ship with this thing. They're doing the right thing by changing Creality print over to the Bamboo Studio / OrcaSlicer version. That's powered by the Prusa Slicer engine, and I just think it works a lot better. And then all of the multiple plate features and all of the options and stuff. I mean, it's just good to see them taking that effort to improve the slicer, because that's something that they didn't have to do, especially since they've sunk so much cost into developing their previous version. I assume that was a hard choice to be able to switch everything over. I wish this bed was a little bit lighter. It's constructed out of an aluminum carriage plate, and then on the bottom of that you have 2 linear bearings bolted to it, and then on top of that you have the heated bed bolted to it. I think they could have done a better job optimizing this for weight. For example, that carriage plate could have been stamped. You know, they stamped it to cut it out, but then they could stamp it again to add some folds and bends into it to increase the stiffness without increasing the weight. And that would probably allow them to get away with removing more material for a similarly strong bed attachment here. And, you know, you definitely want to be cutting weight on this thing if you want to get those acceleration limits higher. The last thing that I'd complain about is the filament runout detection sensor. It's located on the side right here, but really it would make more sense to put it somewhere else on this machine. I don't know where that is, so for me I just have it attached to the side here with a spare piece of filament jammed in it so that it thinks that it always has filament. I don't really use filament runout detection sensors, so I don't like miss it not being there on this machine. But if you have to have one, I think the best place for it is either directly on the tool head or like right after the filament spool. I think having it built into the tool head makes the most sense. That's the way that Bamboo Lab and Prusa do it, and I think it's a great way to solve the problem, especially since you have a little tool head board built into this thing right here. It's just a matter of adding a little switch and setting up a little mechanism that rides along inside of this print head to tell you when you have or don't have filament. But yeah, other than that, I don't have a whole lot to complain about with this machine. I think they did a pretty good job with it overall. I think it's really awesome to have a slightly larger machine for just making large parts like this. And the hardware seemed solid, and I was able to print with it just fine. Also, in a lot of the B-roll you might have noticed in the background, I was working on the Prusa MMU system. So, pardon the bagel here. Yeah, I put this together, and I'm going to be doing some multicolor printing using the Prusa MMU 3 because that's supposed to be pretty good. And I bought that with my own money. That's just something that I wanted to try out. And the other multicolor solution on the market I hate for reasons that we won't get into right now. Big thanks to JLC 3DP for sponsoring this video. Also, thank you to Creality for sending this machine over for me to check out. And thanks to all my patrons for supporting me and allowing me to keep this channel going. One last thing that you might be interested in, Creality is doing a pre-sale for their K2 Plus printers, and they're going to be doing like ridiculous discounts for that machine. And I really hate that they're doing that because now it's tempting people into pre-ordering the machine when they basically know nothing about it. It's supposed to be a 350 by 350 multicolor printer. Hopefully it works pretty well, but we don't know right now. But if you were planning on buying one anyways, I'll leave a link to it in the description below. They're going to be doing early bird like stuff, so you can get up to 50% off on the machine with the multicolor unit. So, you know, it might be worth checking out. That'll be cool to see. Okay, well, that's about it for this episode of Nathan Builds Robots. Thank you for watching, and I'll see you in the next episode.